Hi, I am Kalyan Reddy Daida and I will be your instructor in this course, Terraform on Google Kubernetes Engine, DevOps, SRE, IaC, 40 real world demos. So here we are going to implement everything in a practical demo manner. So first what we do is we are going to go ahead and then understand Terraform fundamentals in a detailed manner. So for that purpose, we are going to implement close to 8 demos and where we will master different concepts of Terraform. We'll understand what are Terraform commands and what are language basics for Terraform and what are meta arguments like provider and for each and then count, and also learn about input variables and output values. And in addition to that, we'll also learn about how to use Terraform data sources. All these things we will implement as part of fundamental demos. And once we complete the fundamental demos, we'll move on to implement GKE different types of clusters, like creating GKE public standard cluster using Terraform and creating GKE private standard cluster using Terraform, and what all resources are required for that. Example, when we are implementing private standard clusters, we need cloud NAT and cloud router related resources. So those also we are going to implement. And from security standpoint, if we want to make more secure for our GKE clusters, we can also implement GKE private standard cluster with private endpoint. Even that we are going to automate in one demo using Terraform. After that, we are also going to create a GKE private autopilot cluster using Terraform. So here we learn about different types of clusters and automate them using Terraform. Once that is completed, we'll move on to implementing GKE scaling features, which are like GKE cluster autoscaling, horizontal pod autoscaling, and vertical pod autoscaling. So all these things we are going to implement both using YAML manifest and also using Terraform manifest of Kubernetes. There we are going to use Kubernetes Terraform provider for implementing them in Terraform. And once we complete the GKE scaling, we will focus on learning about GKE storage. And for GKE storage, we learn about 4 types of storage. One is Compute Engine Persistent Disk CSI driver, wherein we mount the Google Compute Engine Persistent Disk to our workloads running on Kubernetes clusters. So that we are going to implement both using YAML manifest and Terraform manifest. In the same way, we will also create a Cloud SQL MySQL database which is a private database where our workloads in GKE cluster will be able to connect to this Cloud SQL completely privately, and this Cloud SQL database and our custom VPC will be in VPC network peering. So those things we will implement, and for our sample application, instead of using this persistent CSI driver related persistent disk, we will also use a managed database as a storage. So Cloud SQL MySQL database. So once that is done, we will learn about using cloud storage as underlying volumes for our workloads running on Google Kubernetes Engine using Cloud Storage Fuse CSI driver. So this also we will implement both using YAML and Terraform manifest. After that, we will go to GCP file store CSI driver. So here we will mount our file store to our workloads running on GKE cluster. So this also we are going to do with YAML and Terraform manifest. More or less, most of the demos will ensure that not only YAML and not only Terraform, both things we try to implement here. Now, let's see. After implementing GKE storage, we'll focus on GKE gateway API, right? So earlier we used to have ingress, and now ingress is frozen. All the new changes are coming to only gateway API. So this is a latest feature, and in future we need to use only gateway API for load balancing. So for that purpose, we have close to 13 demos implemented only for GKE gateway API. So we'll start with implementing basic gateway API basics, like learning about gateway, HTTP routes, and all the information about them. With that, we'll create a cloud regional application load balancer. So this we are going to do using YAML and also Terraform. And after that, we'll go and then implement gateway API static IP. So for our load balancer, how to integrate GCP external IP address, so that we are going to implement. And after that, we'll move on to implement gateway API SSL related concepts. So one way we will implement is using Kubernetes secrets, and the other way we will implement is using GCP certificate manager. And once these two are completed, and here we will use the self-signed certificates only, and after that we'll go ahead and then implement a HTTP to HTTPS redirect demo. And once that is done, we'll focus on some routing related solutions like gateway API routing, context path based routing, domain name routing, and traffic splitting. So these demos we'll implement in gateway API. So we need to remember that whatever the demo we are implementing, it is eventually going to create a cloud regional application load balancer, and inside that these settings will be applied on Google Cloud Platform. So everything we are going to write using YAML or Terraform manifest using gateway API related things, and then those will create a cloud regional application load balancer with all these settings. And after that we'll also implement gateway API with health checks and session affinity. So these health checks and session affinity doesn't come under gateway API, but these come under custom GKE policies which you can integrate with gateway API. So we'll create these health checks and session affinity in this respective demo. So for our applications, whatever we are load balancing using load balancer, it is very important to implement health checks and session affinity. So using the custom GKE policies, those also taken care. And next is cloud domains and cloud DNS. So in this demo, we'll exclusively learn about these two services in detail. And once we got the hands-on on those two services, we'll go ahead and then implement demo 11 and demo 12. So in demo 11, we'll focus on gateway API prod grade SSL. So we will generate a production grade SSL certificates using certificate manager plus DNS authorization in certificate manager. And we'll use the cloud DNS for managing the DNS records, and we will use the cloud domain as a domain registrar. So in demo 11, and when we go to demo 12, it will be similar to demo 11, but only thing is we will use a external domain registrar like Namecheap or GoDaddy. Here we have used AWS Route 53. So using that, again we will generate the production grade SSL using certificate manager plus DNS authorization plus cloud DNS plus AWS Route 53. Using this, we will implement one more demo. And after that, we'll also create a cloud global application load balancer. So here, so far from demo 1 to demo 12, we have used the regional application load balancer. But in the last demo of gateway API, we will focus on implementing global application load balancer. So once these are completed, we'll move on to implement GKE INFRA DevOps. So in this INFRA DevOps, first we will start with learning what are Terraform modules. So how to use the pre-built Terraform module which is present on Terraform registry. So once we get the hands-on on that, we will create a custom Terraform module for GKE cluster. So once that is created, we will implement a GKE Infra DevOps, which means we will create using GitHub and Cloud Build, we'll create pipelines so that using those pipelines, we can create dev, QA, staging, and production environment. So you will have a dev cluster, staging cluster, and production cluster like that. So for cost saving and all those reasons, we have used only two environments here. One is dev environment and production environment. So in these pipelines, it will create dev GKE cluster and prod GKE cluster. So after that, we'll move on to the next thing. So after infra DevOps, we'll focus on implementing workload DevOps. So in workload DevOps, we are going to create a custom Terraform module for our Kubernetes deployment resource, and then we are going to implement GKE workload DevOps, GitHub plus Cloud Build. Using these things, we will implement it, which means we will implement our dev application to be deployed to dev GKE cluster and prod application to be deployed to prod GKE cluster. So till there, it is good. But in this workload DevOps, we currently don't have any continuous integration concept, which means like you have a application, you made some code changes, and those code changes you have checked into your GitHub repository, and those code changes will be promoted to, means like those code changes will be moved to a pipeline to create a Docker image, means like it will build a Docker image and push it to artifact registry. So that part of things are currently not there in this GKE Workload DevOps. So in the next demo, we'll create a GKE continuous integration thing where you will use GitHub Cloud Build and Artifact Registry to implement that use case, continuous integration related use case for your application. So you make the code changes, check in, automatically a Docker image will be built and push you to Artifact Registry. Now you have a CI pipeline built and ready. In this last demo, you will focus on implementing a continuous delivery. So whatever the workload DevOps you have implemented here in demo 2, so that one you will stitch it with this CI demo. So which means once you have a new Docker image present in Artifact Registry, that Docker image will be picked by this workload DevOps CD pipeline, and then it will deploy to your dev cluster. And if you want to promote that to production cluster, you can also promote that. So the whole thing we have implemented using different DevOps concepts there. So when you go there, you will get in a detailed manner. So you see these all 7 demos, whatever you see here, Infra DevOps and Workload DevOps are tightly integrated. So one after the other, we need to incrementally implement them. So these are the 40 demos we are going to implement as part of this course. And now if you see all these 40 demos, you can see everything is documented step by step in GitHub. So you can see from 01 to 28, and in 21 GKE Gateway API, you can see 01 to 13. So and in every of the and every demo, so if you go here, example, if you take it any of the demos here, so you will have project 1 is Autopilot cluster, project 2 is your YAML manifest, and project 3 is Terraform manifest. So like this, everything are arranged in a very neat manner. So if you see here, in project 1, you will have GKE cluster Terraform manifest, and in project 2, you have those equivalent Kubernetes YAML manifest, and in project 3, you will have equivalent Kubernetes Terraform manifest, so that you can continuously test using YAML manifest and learn them, and you can also test using Terraform manifest and even learn them. So accordingly, it was arranged. And all these are the services we have used as part of these demos. So 18 plus GCP services and many more sub services under each of these services also we have used. And all these things automated with Terraform. And whatever the GKE clusters we are creating, we have used custom VPC to create them, custom subnets to create them, and VPC network peering between Google Cloud services like Cloud, SQL, and all those things also we have implemented using Terraform. And these are the GitHub repositories we need to use. Starting with course main repository, you can see here Terraform on Google Kubernetes Engine, so where all the code is present. And after that, we have the Infra DevOps repo, App DevOps repo, and Workload DevOps repo. So these things you will use where it is when you reach those respective demos. But entire course related, all the YAML files and Terraform manifests are present in the course main repository. Most of my students request for a detailed introduction on what they are going to learn as part of this course. So if you are good with this introduction, you can skip the lecture from here on and then move on to the next lecture. So if you want a detailed introduction, so let's go ahead and then understand all the things in a visual manner what we are going to learn. So we are going to start with Terraform fundamentals, wherein we are going to learn about Terraform commands, Terraform language basics, and Terraform meta arguments like provider and count and for each. After that, we will also learn about Terraform input variables and output values. In addition to that, we will also learn about Terraform data sources. So close to 4 hours we are going to spend on learning Terraform fundamentals. And here there is no Kubernetes or GKE. With plain Google Cloud VM instances, we are going to learn and implement these topics. And once we learn these things, we'll move on to automating the Google Kubernetes Engine related use cases. So from Terraform perspective, we are going to learn about all the commands and also different blocks in Terraform language. So those different blocks, how we are going to use when we are writing the language. So all the language basics we are going to learn. And some important concepts like Terraform state files and Terraform backends and also Terraform remote state data source. So these things also we are going to learn in detail. So after that, once we are good with Terraform fundamentals, we'll focus on learning about or automating the Google Kubernetes infrastructure. So we will start with creating a standard public cluster and everything via Terraform only, which means like we will create a custom VPC, custom subnets, and also we'll create a GKE cluster and also GKE nodes. All those things we are going to create using Terraform only. And we'll deploy a sample application and test it on public cluster. After that, we'll go ahead and then create a GKE standard private cluster. And for this private cluster also, we will implement outbound connectivity using Cloud NAT and Cloud Router. In addition to that, when we are implementing the private cluster, so we will ensure that we have the public endpoint access for administering the tasks on this cluster as part of this demo. In addition, we will also focus on implementing cluster autoscaler related features as part of this demo. From there, we'll move on and implement horizontal pod autoscaling concept and vertical pod autoscaling concept. And once these are done, again we will implement one more GKE standard private cluster but with private endpoint. So private endpoint in the sense, for your Kube API server private IP, we need to access it only internally from Google Cloud only. We cannot access it via internet. So there is no public endpoint to access the GKE cluster. So for that purpose, we'll also create a Bastion VM in our Google Cloud, and we'll connect to that Bastion VM, and from there we will run the kubectl commands. So entirely a secure cluster we are going to create as part of this demo. And once this is completed, we'll focus on implementing GKE Autopilot private cluster. So far we have implemented all the demos with standard clusters. After that, we'll move on to Autopilot private cluster. And from here on, we are going to use Autopilot cluster for all our demos. And once we automate and implement this Autopilot private cluster, we'll move on to learning about Kubernetes storage. So there we will learn about Kubernetes storage classes, persistent volumes and persistent volume claims, and all these things, all these resources we are going to create using Terraform. And we'll also implement a simple user management web application here. So wherein we have a Java Spring Boot web application and underlying database is going to be MySQLDB. And this MySQLDB we are going to use from the Compute Engine persistent disk in Google Compute Engine. And this we are going to use using Compute Engine persistent disk CSI driver in GKE cluster. So using that, we are going to mount our disks to our pods in our Kubernetes cluster and implement that in a detailed way. So we'll implement that both using YAML manifest and also using Terraform manifest. So this is GKE persistent storage using Compute Engine persistent disk. So once we implement and get a hold on that, then we'll go ahead and also see for the same application, instead of using a persistent disk, Compute Engine persistent disk, can we use managed Cloud SQL MySQLDB. So for that purpose, first we will try to automate that using Terraform to create a Cloud SQL MySQLDB with private IP, which needs VPC network peering between Google Cloud and also our customer VPC. So for that, we'll create this private service connection between our VPC and also Google Cloud's service producer VPC network. And we'll test once the Cloud SQL MySQLDB is created. We will test by creating a simple VM instance in our VPC network and access it with a private IP. Once that is done, now we'll go for the bigger implementation where we will implement user management web application will be deployed on the GKE Autopilot cluster, and which will connect to the Cloud SQL private IP, and the entire communication is going to be internal to Google Cloud and which is going to be private. So once we complete the Cloud SQL MySQL storage concept, then we'll move on to cloud storage buckets. So how to mount cloud storage buckets to the workloads running in GKE cluster. So for that purpose, we use the concept called Cloud Storage Fuse CSI driver. So we'll learn about that and we implement that and then test it. So we'll mount the cloud storage bucket to our workloads running in Kubernetes for specific pods and then test it. So that's about cloud storage, Fuse CSI driver storage in GKE. Next, we'll move on to file store. So we'll implement a file store related storage mounts that will be mounted to our workloads in GKE cluster. So that we are going to learn in detail, and everything automated via Terraform. Even we will test it via YAML also, and we'll test it via Terraform. And once we learn about file store storage, so with this we have learned about 4 types of storage. One is persistent disk CSI driver, second is cloud storage Fuse CSI driver, and third is file store CSI driver, and fourth is regular managed Cloud SQL MySQL database. So once these 4 storage demos are completed, we'll move on to learning about gateway API. So this is very important topic going forward in Kubernetes clusters. Why? Because if you see here, earlier we used to create load balancers using application load balancers using ingress controller or ingress services, right? So now if you see, ingress is frozen. All the new features are being added to the gateway API. So which means we need to start using gateway API for spinning up load balancers in our clusters. So that said, this is a latest concept which I have introduced here, and we are going to have close to 13 demos to understand this concept in detail. So here we'll start with gateway API basics, and we will learn about what is gateway and then what is HTTP route, how to define them in both YAML and Terraform formats. We will implement it, and how to define HTTP listener in them, and how to define a default backend in the route. All these things we are going to learn in this basic demo, so which will create a regional application load balancer in Google Cloud. And once that is done, we'll go ahead and then implement a static IP related demo. So how to create a cloud external IP address in Google Cloud and associate it with the gateway. So that we are going to implement. In addition to that, we'll also create self-signed SSL certificates, and we will mount those self-signed SSL certificates to our gateway using Kubernetes secrets concept. Even that we are going to implement. And once that is done, instead of Kubernetes secrets, can we use GCP certificate manager for managing the SSL certificates. So we'll create a certificate manager object with self-signed certificates and mount this or reference this certificate manager object in gateway. So we are also going to test this using gateway API. And once that is completed, we'll focus on implementing HTTP to HTTPS redirect. So when we provide a URL in our browser, it will automatically redirect to the HTTPS URL. In production grade implementation, this feature is a lot, means like it is a very important feature. So how to implement that in gateway API, we are going to do it here. So how we will create HTTP listeners and HTTP to HTTPS route, and all those things we are going to implement. And once this is done, we'll learn about some routing things which we can implement using gateway API and HTTP routes. One is context path based routing. So if you have 3 applications and if you want to go to 3 different applications here with 3 different context paths, so how to implement that? /app1 should go to app1 application, and /app2 should go to app2 application, and root context should go to app3 application. So all these things we are going to implement in HTTP route, and accordingly we are going to learn it. Once context path based routing is implemented, we'll focus on implementing domain name based routing. So here we will implement, like for the same 3 applications, if your DNS URL is app1.yourdomain.com, then the request will go to app1, and if it is app2.yourdomain.com, it will go to my app2. And if it is any other URL, default.someyourdomain.com, then it should go to my app3. So accordingly, we will define the HTTP routes and implement it. So that's about domain name based routing. In addition to that, we will also implement traffic splitting. This is another very important feature. So when we are introducing a new release, we can split around 5% or 10% of traffic to the new application version and then test how it is behaving. So for that purpose, we can use this feature more effectively. So here we will implement a traffic splitting demo with 50% traffic to my app 1 and 50% traffic to my app 2, and then verify that in detail. And this split we can change based on our needs, but here we try for testing purposes, we give 50% for my app 1 and 50% for my app 2. So that's about traffic splitting demo. And once we learn about traffic splitting demo, we'll focus on learning about very important concepts from load balancers perspective, which are health checks and session affinity. So these things we will implement at the cluster IP service level, and those things are GKE custom policies. So these custom policies we will attach it to the cluster IP service and then implement it as part of this gateway API and then test it in detail. So once session affinity and health checks are completed, we will focus on implementing more production grade implementation, like instead of using self-signed certificate, using certificate manager, we will generate a production grade SSL certificates with DNS authorization against cloud domains, registered domain, and also cloud DNS managed zone. So here we should have a registered domain in cloud domains, and we need to create that as a managed zone in cloud DNS, and we also need to implement a DNS authorization for the certificate whatever we are creating, and if it is successful, it will generate a production grade SSL certificates. So these certificates again we will configure it in our gateway. So all these things we'll do with both YAML and also Terraform. Once this is done, we'll also move to one more use case wherein instead of using cloud domains, right, we can also use any external domain register like Namecheap or GoDaddy. So we'll use AWS Route 53 to implement the same use case, generate production grade SSL certificates, and then test the entire use case. And once that is completed, we'll also create a global application load balancer using Gateway API. So all the previous demos we have implemented are related to regional application load balancer. So we'll also test with global application load balancer. So once that is completed, we'll learn about Terraform modules concept in detail. So this Terraform modules concept, we are going to use the pre-built Terraform modules present on Terraform registry and then test it as part of first module demo 1. After that, we'll focus on building a GKE custom Terraform module. So GKE cluster, we'll create it as a child module and call that in the root module and then test it. So here we'll build a local Terraform module which is nothing but GKE cluster. And once that is done, we will implement a GKE INFRA DevOps for Terraform configs. So we have a GKE related Terraform code to create GKE autopilot clusters. So that code we will implement the DevOps pipelines for that using GitHub, Cloud Build, and also Cloud Build app from GitHub Marketplace. So using these things, we will implement or create base dev environment and prod environment using Cloud Build triggers, and there we'll learn about connections, link repos, triggers, all these concepts we will learn. And once we have this dev and prod base environments created, we'll also focus on changing the settings in our environments and applying those changes across environments one after the other. And here we are going to use Git pull request and merge related options to implement that use case. So once we implement the infra DevOps, right? So the next thing is we also need to implement workload DevOps. So that also we are going to implement now. So here as part of demo 25, 26, 27 and 28, we'll focus on implementing the workload DevOps. So first we'll start with creating a Kubernetes deployment custom Terraform module, and then after that we will implement Kubernetes workload DevOps pipelines for dev and prod environments for a simple application, and then after that we'll also implement continuous integration pipeline with artifact registry as part of demo 27, and finally we will implement continuous integration and continuous delivery end-to-end implementation. So here we are going to use GitHub repositories, artifact registry, Cloud Build app, Terraform configs, and GKE clusters. So let's understand at a high level, right? So we are going to create a simple Kubernetes deployment module as a child module and call it in the root module. So once that is done, we'll go ahead and then implement the Kubernetes deployment DevOps, which is nothing but workload DevOps implementation we are going to do. And we'll initially deploy a simple v1 version of our application, and later we will update it to v2 with manual changes, which means our Docker image will try to change the version from v1 to v2 and then test it. Once that is complete, instead of doing it manually, we need to do it automatic, which means we need a continuous integration pipeline for our application, whatever we have deployed here. So for that purpose, we'll go ahead and then create a continuous integration pipeline using GitHub, Google Cloud Build, and Artifact Registry. So what we will do is, whenever we check in a new code to our application, right? So automatically it will trigger the Cloud Build CI pipeline, and it will generate a new Docker image, and that will be pushed to the Google Artifact Registry. So that's what it is going to happen as part of this pipeline. So we will integrate this CI pipeline with CD pipeline. So what exactly that means is like, so this is the complete CI pipeline which we have seen in our previous slide also. So that pipeline, we will integrate it with our CD pipeline, so which we have implemented as part of workload DevOps. So this CI pipeline, right, once it creates a new Docker image, the same Docker image related tag, using that it will build a new Kubernetes deployment TF file and push it to our Terraform configurations where we have the Kubernetes code to that GitHub repository, and it will run the CD pipeline to pull the Docker image with the tag and then run the Terraform plan. And in addition to that, we will follow the same DevOps approach to implement or apply those changes for multiple environments, which means first we will merge those changes to deploy in dev environment, and after that we'll merge those changes to deploy in prod environment. When we see it on a high level, it looks very complicated, but when we implement it, so we have a detailed documentation for all these use cases, and we went very step-by-step manner for all these demos. So it is going to be pretty easy once we implement it in a practical manner. So I'll see you in the next lecture. Until then, bye bye. Thank you.